Hey, everybody, welcome back. I'm Susan Lindner, your host of the Innovation Storyteller Show. Today, we're talking about shifting perspectives. I'm going to be asking you to look through a lens and a technology that perhaps you hadn't even considered or maybe never even heard of before. I'm really excited to be joined today by Rob Devlin, who is the co-founder and CEO of Metalenz, a fabless optical semiconductor company pioneering the commercialization of meta optics. This is not the metaverse. This is a whole other way of thinking about optics through a semiconductor lens. And we're going to get into all that. So get ready to geek out a little bit today on technology. But of course, more importantly, we're always going to focus on the story that we tell to get breakthrough, really even bleeding edge technologies to their finish line. A little bit more about Rob. This work that he's doing focuses on moving scientific research towards real-world applications that have already led to 15 patents and additional patent applications in the works. In 2022, Rob and his team at Metalenz announced the world's first meta surfaces in market consumer devices via partnership with semiconductor giant ST Microelectronics. Prior to co-founding Metalenz, Rob completed a joint BS and MS in electrical engineering and materials science at Drexel, and a PhD from a little-known place called Harvard University in applied physics with Professor Federico Capasso. I hope I'm saying that right. His research has spanned the topics of nanofabrication, nanophotonics, and materials science. He has authored or co-authored 20 plus publications that have provided critical advances in the emerging fields of metasurfaces, one of which was selected of the cover of Science Journal and voted one of Science's 10 breakthroughs of 2016. Rob, thank you so much for joining me today.
Thank you, Susan. Great to be here, and very much looking forward to talking about what we're doing at Metalenz and how we got here.
Well, fantastic. So let's dive in. How did you get here? How did you start working on what would become Metalenz?
Yeah, the group Federico Capasso, you really got the perfect Italian pronunciation in there, so you were right on.
Federico Capasso,
Yeah,
yes.
he would love that. No, so the group at Federico Capasso had been working on these meta surfaces really going back to about 2007. Metamaterials, generally these engineered materials, right? So in nature, we're given certain properties of materials that are based off of the elements inside of them. But what we found as we're able to make things smaller and smaller and engineer really small structures, mainly driven by the silicon fabs developing processes and everything like that, is that we can actually take materials and engineer them with man-made properties that you wouldn't find from natural materials. So this is the general concept of a metamaterial. And these metamaterials have given all kinds of great promise, things that you can't do with natural materials. You can cloak things so that you make them seem invisible. You can route sound so that it goes in strange ways, because with these metamaterials, you have control over the material properties based off of how you shape and organize everything within them. So lots of promise, but no real application because they were too complicated often to even really make or manufacture. And so in the Capasso group, what they focused on is how can I make this extremely simple in terms of processing and fabrication so that I can take metamaterials and move them from, let's say, just curiosities within the lab, things that you can kind of make one-off devices, and then make them something that you could mass produce. And so they came up with the concept of this meta surface, where essentially what they showed is you could, with a single nanoscale device, something that has a thickness about 1/1000th of the width of a human hair, completely control all of the properties of light. And most importantly, what this did is it used a set of manufacturing processes that already existed out there from the giant semiconductor manufacturers, which are making all of the chips that go in our phones, so making billions and trillions of chips every day. So this was sort of the initial innovation in the Capasso group, was to say, how can we take all of these exciting things and make them in a way that is manufacturable?
And
And when I
scalable.
Yes, exactly. Scalable, manufacturable. There's so many great academic technologies that really haven't made it out of academia because they haven't had that second piece of the manufacturability, the scalability. And here the idea, the fundamental concept was to design the device in such a way that it would use existing infrastructure that was already mature in the semiconductor world.
Cool. So I think what's really fascinating is that you're taking lenses, right, that have traditionally been manufactured in a very different way. And even from academic circles, really thinking about potential applications, right, for where this technology could go. But what's really exciting is that you're manufacturing lenses using a semiconductor process, which builds out this entire opportunity. Like that's an innovation in its own right, right? Just thinking about how we make them.
Yeah.
Um, and then how we get them to market. But tell us what is the innovation itself? What is the Metalenz that reaches the market?
Absolutely, yeah. If you look at lenses generally, they really haven't changed in hundreds, arguably thousands of years in how they have been working and how we've used them. So whether it's your camera that you're using or your eyeglasses that you're wearing, the way that these lenses typically work is you have a big bulky material that you bend and shape and mold. So your lens normally is curved in
We're
order to
talking about glass, right? We're just talking about shaping glass in a particular.
exactly.
Uh,
You're going to shape and mold the glass. You have this big bulky material. It has a fixed set of properties, but you turn it into a curved thing, and then what you're able to do is collect an image or correct eyesight. And so this is the way, again, going back to as far back as Egyptian times, they were making curved and molded lenses. That has certain limitations in what you can then end up doing with those lenses, or you often need, say, 5 or 6 lenses in a traditional camera in order to be able to produce a good image. So we're talking through a webcam right now. If you were to explode out that webcam, it's not just one curved lens in there. It's probably 5 or 6 curved lenses, one stacked after another in order for you to make a good image. Same with the camera on your phone, same with anything that you're doing in lenses and optics. And with these meta surfaces that we make, what you're able to do is actually take the function of 5 or 6 of those lenses and reproduce it in one completely flat and planar layer. So you get rid of this curvature, you shrink everything down so you can make it smaller, and then even more interesting, again, these are metamaterials, so you can do things that you couldn't do with traditional lenses. There's other information and data in light in what is out there our human eyes don't see or our
okay.
traditional cameras don't see that you can then take these metasurfaces and extract. So it reduces the complexity, it reduces the size of traditional cameras, which have really hit a complete bottleneck at this point in their overall development. We really can't make them smaller. And then it allows you to access information that simply our vision systems or even the vision systems on our devices can't access, can't see, can't visualize today.
Do we want to make them smaller? Is that the intention? Like, do we want tiny itty bitty lenses on our cameras? Is that it? Because we want to.
Certainly, yeah, I think if you look at it, there's a couple of things that ends up happening there is that if you can make it's still going to be best from a traditional optics, traditional lens perspective to make things bigger and longer to make really high quality video or take really high quality photos, right? It's not as if when we made camera phones, the big DSLR cameras or for a sports game, it's not as if they stopped using the big video cameras that are capturing all of those images. So the more you can compact things down from those big devices, the more realistic it is for you then to scale it into devices that go in our pockets. So it can improve camera phones, it can improve video that you're taking. It can also take really complicated devices that have sat and been locked away in medical laboratories or scientific laboratories and start to put those in our pockets every day. So it's about that scaling of the size also means you're probably scaling the cost. And then it also means you can put it in places that become more portable, more mobile, and millions, if not billions, of more people then have access to complicated scientific imaging approaches that can really change our lives and change the way that we interact with the world.
I just keep reflecting back to like James Bond and like what else he's going to stick a camera in. Like, at this point, it's going to be like hello with my index finger and just stick a camera in my fingerprint, right?
Yeah, I mean, it's certainly like that. And then it's even beyond that where you can start to say, take tabletop sized equipment that is in medical labs that does medical assays. Put that in your phone, put that on a watch, put that in all of these places where by scaling the size, by reducing the complexity, it lets you actually make this cheaper and be able to put into consumer devices. So it allows you to take technology that really has been locked away, that people have to travel remotely to in order to use, and put it in everyone's devices. So it's sort of this taking of complicated sensing, complicated scientific medical sensing, and making it available to everyone.
Yeah, even microscopy, right? I mean, like you could completely change how microscopes are fitted for image capture, not just for viewing.
Yeah, absolutely. And some of the things that I mentioned with these metasurfaces, you can also access this information that the traditional optics are throwing out. You can use them to do things like material characterization or look
What is
at
that
biomarkers.
material characterization?
Yeah, you can basically, a traditional camera like we're using right now
Uh-huh.
isn't going to tell you that you're looking at plastic or isn't going to tell you about the chemical makeup of the material. It won't tell you about biomarkers in skin. But there are optical and there is signatures in light that can actually tell you about what the material you're looking at is made up of, as long as you have a way to be able to access that, which you can with metasurfaces. You can now use these in order to do things like material assays. You can tell whether something is man-made or is a natural object, all sorts of things that you can do, which traditional optics simply can't.
That's so cool, right? I mean, like I think about applications at NASA, right, of being able to detect all the different lenses that are needed in space to detect different atmospheres, to detect different rock formations, and
Yeah,
uh, and that's all done with spectrometry too, right?
yeah, yeah,
Um,
exactly. So you can then take a metasurface in this case and take those tabletop-sized instruments that cost thousands of dollars. You can scale them in size to put them in devices. But then this other piece of the manufacturing, which we talked about, which is one of the big innovations here, you're leveraging that semiconductor manufacturing, which means they're making hundreds of thousands to millions of these devices in a single day, which means that they can be very cheap. So it really unlocks it in two ways. It unlocks it from shrinking the size of the instrument, and it unlocks it by making them very, very cost effectively.
that shift, I mean, I think if the last 20 years or maybe even 30 years has brought us from a technology philosophy is democratization of technologies in ways that we hadn't thought possible before. And
Yeah.
the simple ability to put a lens on something that never had a lens before is
Yeah.
like a whole world, right? Of we think about having to buy, I mean, in olden days, one would buy a camera,
Yeah,
right?
exactly. I mean, even in that simple scenario where we took cameras from sort of an amateur niche type of application and put it onto phones, and then everyone started having cameras and video, the way that's changed our perception of the world, because now you're able to immediately see someone else's perspective from China or from some other country. It's helped with social justice by being able to see certain things, and just the way we've used phones now to move through the world just from the camera perspective has been a complete shift. And with these metasurfaces now being able to put cameras in more places or being able to bring in entirely new equipment or new sort of scientific and medical equipment to devices and to millions and billions of people, it's another big shift. And really, since the camera has been put on the phone, there hasn't been another big innovation in optics or sensing on the phone. That's about 10-year cycles that runs where the phone has done something that has been really earth-shattering or sort of world-changing. And I think with what we're doing at Metalenz now, by bringing in this entirely new form of sensing there, we can give people an entirely new set of information, new applications that we're not even thinking of yet, the same way when cameras first went into phones.
Yeah. So tell us a little bit about how you pitched this idea to venture capital firms. How did you pitch this? I mean, you're coming out of a prestigious institution like Harvard, right? There's a little bit of your, collaborators and mentors certainly had a great history, but how did you pitch this idea and how did VCs respond?
It was definitely a big challenge for us in the beginning because it is highly technical. And then even more so, this is hard tech, right? So everyone wants a SaaS company today, right? Uh,
Hey, give me some easy software with an annual recurring revenue, and I know how to value that.
exactly. And I can keep my headcount low and just sort of crank things out. And then I just, in a couple of years, can characterize this. No infrastructure, no overhead, et cetera, et cetera. So that was the first big challenge. This is hard tech. It's also then very technical. So if you actually look at the early investors, a lot of the companies a lot of the investors we have are corporate venture. So it actually was the semiconductor world that saw, wow, this is an entirely new thing that can move into the semiconductor foundries and can completely change our devices. And so it was actually technical to begin with. So we were dealing with some of the early investors are like Intel Capital, for example, or 3M Ventures, Applied Materials, these giants in the semiconductor world. We also did have traditional VCs, and there we really had to think about how do we relate this to the impact, the overall vision, which frankly, at the time when we were starting the company, was very far off. We just said, hey, we have these really interesting lenses. We can do things you can't do with optics, but we think this is going to reshape completely how people are going to interact with the world around them. And I think it was that piece where a lot of, even in the hardware world at the time, a lot of the focus was around things like self-driving cars, and there was a lot of innovation on the sensors that people were using. And we stood out to the investors as, wow, these cameras and lenses have not changed in a very, very long time. And here is a technology that can finally reshape this. We've
Yeah.
seen cameras in
That alone,
phones.
right? And that alone is like ding, 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 ding. Like, give me an industry that hasn't been reinvented in thousands of years. Okay, I'm listening,
Yeah,
right? So we got to know our audience and what really matters to them.
exactly. And I think that was the sort of thing where in many other investment areas, even within hard tech, it was becoming saturated. But for us, we had a very unique approach because people weren't talking about how they're going to reshape optics because they haven't had a new type of optical technology in hundreds, if not thousands of years. So it really stood out, and people could immediately say, "Oh, and I'm already using cameras, and they're not changing. They haven't changed in a long time." Or I want to be able to do much more with my phone than just take pictures or just have my phone see what my eyes can already see. And that part connected with the VCs, especially because they said, this isn't just incremental. This could be sort of a shift in industry. This could be a shift in the way that people actually interact with the world around them.
It's really fascinating when you put it in that context, right? We could be, this kind of technology could really be changing our behaviors from an industry level, but also on the individual level.
Absolutely. I think that's sort of for us, and going from a hard technical PhD sort of engineering mindset, but then also being able to look what it's going to be like 10, 15 years down the road if this really has the impact we believe. That's always one of the big challenges, I think, when you're normally grinding away, trying to get results, sifting through data, all of those things. And I think that the piece that we find the most exciting is just that. It's that we really think that this can change the way that people will interact with the world. Again, our devices today, our cell phones, our webcams, they're actually giving us the same information that our current visual system is picking up, right? We're just seeing what our eyes already see and what we can already see as humans and individuals. What we can potentially do with metasurfaces is give people a new view, a new sense of the world that we haven't been able to access today.
Yeah. And it's funny, right? I mean, we're taking the curvature off the lens. Like we're making this lens the ability to be flat and still deliver the same or shaped or rounded or what have you, right?
Yeah.
And so the variability is endless, it sounds like.
Yeah, absolutely. It's that case of we are now able to really control the information, the light coming in just about any way that we really want to because of the way that that these metasurfaces have rethought lenses, have rethought the need for this curvature.
So where do you like, so take us on a little vision run for a minute, Rob, if you will. Like, so you're daydreaming in a hammock somewhere in Jamaica, right? And you're thinking about the potentials of where this technology can go. What do you see happening potentially? And maybe even some of the folks that you'd want to partner with in order to make that heaven come true.
Yeah, I certainly think one of the things that there has been a lot of innovation around and certainly gets a lot of attention, and there, I guess two different places has been there has been a lot of advancement on the sensors that are going into devices, and there has been a lot of advancement on the algorithms, especially with AI and machine learning. Those are the really big areas of explosive innovation. And I think what we are able to do is actually bring better information into those systems, into those AI systems, into the machine learning systems, because in any case, even you have the best set of algorithms, the smartest set of machine learning algorithms that you could think of, the better information, the more rich information you can bring into the system, the more efficient, the more you'll understand about the world, the more the algorithms will be able to give you back. So I think one of the things that we're really seeing here is that with these metasurfaces, I think you could be able to be doing home diagnostics of biomarkers in your skin. I think it would be able to give us something that is going to allow people to go out and actually measure air quality with their devices. Just a
Oh,
handheld cell phone, you could measure the air quality through something we can uniquely access, which is this polarization information that's in light. So I think it's that case of making every individual and every person have the ability to have otherwise extremely expensive, complicated equipment and now be able to access it. So you can locally measure air quality, you can measure biomarkers in skin. And this couples well with the other innovations that have been out there on the sensors and on the algorithms, where there's a lot of effort, a lot of focus. This does it on the hardware side. And this is a unique case of doing it on the hardware side.
so I'm thinking about like just the fitness industry, right? Or the health and wellness industry. And we think about, oh, I'm going to attach a glucose monitor to my arm. Oh, I'm going to blow into this lumen device, right? And figure
Yeah.
out, but the skin is a great conductor, right? Maybe we can even give ourselves our own melanoma test before we have to go to the dermatologist.
Yeah, exactly. And actually, interestingly enough, one of the products that we have just recently announced and launched, which is Polar ID, this uses something called polarization information and light. And what you can do with this polarization information, there are a few very interesting things, like it can make a very secure biometric signature. So your polarization signature is unique to you. So I can use that to uniquely identify Susan. So it's a very unique signature for you. So it can set up a secure unlock, secure digital payment on every phone just by using your face. But also that same polarization information can be used in things like sensing glucose, or it can be used in things like seeing whether or not a growth is cancerous or not. So if something is cancerous, if the growth is cancerous, if you look at it from a normal camera, the intensity doesn't look different from something that is not cancerous.
Uh-huh.
But if you were to look at this in polarization, they have two completely different signatures. And therefore, we can start to use our own devices at home to maybe take a snapshot and send it off to a doctor who can then analyze the images rather than having to go and go in and have this checked out. And so it's that extra information that now unlocks our devices in a way that we haven't been using them before.
I just think the self-empowerment, right? We talk about democratization, but the self-empowerment that comes from this kind of knowledge is incredible.
Yeah,
And to gatekeep health information feels also kind of really counterintuitive to how we were designed as
right.
human bodies, right? In theory, if we were more attuned, we might know more about what was happening to our body as it was happening. But having augmented opportunities to really observe our own health and wellness is incredible. I'm really looking forward to the day. And then you still have to get off your ass and go exercise, right? Like you can't just
Sure.
like, okay, wow, look at that.
Yeah. Yeah,
Like,
exactly.
it's creeping up there again. Thanks for letting me know. As if
Right.
I didn't know that second piece of strawberry shortcake was already going to have that effect on me. But thank you. But
Yeah.
yeah, we did the work.
Yeah, yeah, and I really do think that that is one of the most exciting things for us here is thinking about it's not only again taking these known applications of the scientific equipment or the medical equipment. They've been locked away from individuals mainly because of the cost and the size of these devices today. But I think the other exciting part here is that when you bring those devices that have only been used and interacted with sort of a select few, is the new applications and new ways that people will use this that will simply develop that we're not thinking of yet, right? It's sort of the same way when you took cameras from the niche form of amateur photography or professional photography and then put it in everyone's devices. I don't think anyone would have thought of all of the different ways that cameras then end up getting used and the different sort of things that have come out from those cameras now being accessible to everybody. So I think that's another exciting aspect of this. It's not just unlocking that equipment and then giving the known applications of it to everybody. It's what can everybody think of when they have access to that equipment.
Right. So at Manufacturers Unite, there's going to be a lot a lot of
Yeah.
data technology and opportunity coming from that revolution.
Absolutely.
So you're also going to Mobile World Congress. You're going to be in Barcelona very soon. So no side trips to Ibiza. So what are you going to be? Are you going to be showing Polar ID at in Mobile World Congress?
Exactly. So at the company we have launched Polar ID. We actually just launched this in with our partner Qualcomm. So at the recent Qualcomm Snapdragon Summit back in October, we have now transferred this Polar ID and it's running on Qualcomm's chip, which is used in most cell phones in the world. So we're running and partnered with Qualcomm here and putting this on their device. And then in Mobile World Congress, we'll be demoing this live, demoing this product that we call Polar ID. So as a company, when we first started out, we focused very much on the lens component. We focused on taking complicated systems that needed 3 or 4 or up to 8 different optics, like let's say a 3D scanning system, and we really focused just on the component, saying, okay, let's take all of these lenses and make them a metasurface.
Uh-huh.
But what we've done, and now that we've been able to launch that product into the market, it's in consumer devices, it's in multiple different devices that are being used and interacted with. It's in tens of millions of different devices at this point. What we did is we said, well, there's a lot more information here that we now uniquely have access to. So we've actually built a full system around the optic because it's so unique. We've designed it to work with a specific sensor. We've designed specific algorithms that use that information, that take the way that our lens can actually parse that information. And this is where we've launched our product that we call Polar ID. So this product, Polar ID, uses this concept of polarization in light, like I mentioned, and every person, every individual has a unique polarization signature. Now, when it comes to unlocking your devices, there's really only one cell phone out there that gives you a truly secure unlock with your face, meaning that it can't be tricked, and that's the iPhone. But all of the other phones would like to have some form of secure unlock. It's just that the existing solution to do secure unlock is too expensive for most of the phones out there. So most of the cases, people default to fingerprint, and fingerprint has all kinds of challenges and problems. So with this Polar ID product, we see this as something that can actually put secure payment, secure face unlock into every phone in the world. The 1.5 billion additional phones that don't have it can now have it, because we can take these complicated systems, simplify them. But more so than anything, what we see is this is a great beachhead market for us to put this new form of information, this new form of sensing into devices. And from there, we can start to build in these other exciting applications like we were talking about, biomedical sensing, biomarkers, and so on.
It's just so cool. I mean, I've been hearing probably for the last 10 years is like the phone is not going to be the end all be all device. But it's become like, I think I remember reading a survey a couple of years ago that said people were more apt to leave a baby in the backseat of the car than their cell phone in a car in the summer. It's just that ubiquitous. And then I've heard forever, well, the cell phone's going to go away and chips will be installed under the skin and we'll have other kinds of devices, or we'll wind up doing wearables more than we'll wind up doing phones. What's your prediction on the hardware given the technology of what a Metalenz can do?
Yeah, I certainly think that one of the things that you continue to see is that even though there is a whole new set of devices coming out, and there's all this talk about augmented reality glasses and things of that nature, it's still
To refer to those folks as glass holes who wore the Google Glass is, I think that was the term for them in Silicon Valley.
I have no comment on that one, but
I
you know,
remember those days.
but I think the reality is that the more you can do on your phone and the more that you can put on there, which is what we've continued to see. People, most, I think it's something like 50% of phone users now make their payments on their phone, right? So there's another example of something that has completely shifted. I know that I make payments all the time with my
All of
phone.
Venmo, right? Change the way we think about buying something on Facebook Marketplace and Venmoing someone standing in front of you.
I half the time I don't have a credit card in my pocket anymore because it's stored on my phone. I can unlock it with my face and I know it's going to be secure and I can pay. So I think that's really, the more you put on phones, the more likely it is that it's going to propagate. I do think wearables and other things like watches make a lot of sense. And this is actually why, and I'm very biased here, so just as a disclaimer, but this is actually why optics and optical technology make the most sense here, because these other types of wearables where you actually have to implant something, some of the glucose monitors you have to sort of pin on, or if you're talking about microchips under the skin, this immediately causes people to sort of shy away or not want to interact with it, right? In optics, everything is from a distance and is no touch, right? It's all something that is remotely sensed. So when we're able to do more with a lens, when we're able to bring new information in with a lens, it's more likely the user will actually be fine with it, because either you're not going to feel it since it's just optically transmitted, or you don't even know that you're interacting with it. Half the time when I unlock my phone with my face, I don't even realize it because it's all with
It's just
invisible light and you're just swiping up. So I think the more you do with optics, and I think in reality, the more you can do with something that is non-contact, which is exactly where Metalens can fit in, because we work with light in ways that people can't, the more likely it is for end users to actually, for it to be sticky, for end users to really continue to use it.
Yeah. I mean, I'm even thinking about simple things like we have cameras installed in our car bumpers. Certainly when I was getting my driver's permit, that would have been a dream
Yeah.
trying to
Yeah.
manage a computer. But I mean, the thought of just where optics can go, right? Where these lenses can take us is really incredible. So with that, I'm going to put you on the hot seat and I'm going to ask you the questions that I ask all folks who come on the show. What is the greatest invention of all time? In the course of human history, what is the greatest invention? Or maybe even non-human history. Why do we have to limit ourselves to Homo sapiens?
I would say that the greatest invention of all time, let's see, I would have to go. I'm gonna go in. This is again maybe showing my bias, and for all of the geeks out there, no pun intended on that one. But I actually think that the transistor is probably the greatest invention of all time. I know it's a more recent one, but to me, the reason that's the greatest invention of all time is I think there have been more uses and more transistors made than just about any other device in human history. So it's
Wow.
that ubiquity that it has really launched. Talking trillions of devices, right? Trillions of transistors. So the and it's another example of taking something that was a big bulky technology from a vacuum tube, finding a way to make it smaller, manufacturable, and then it unlocked an entire new world. It unlocked the digital age. So for me, it's the transistor just because of all of the devices that has enabled. The information age basically has come as a result of being able to then pack the chips and pack transistors into smaller and smaller area. And it's really also a fantastic story in material control and engineering.
So you are the first person to ever, almost 150 episodes. No one's ever said transistor before. So appreciate that. The other is we are here to dispel the myth of the one wizard innovator model. Everything.
I very much appreciate that.
So if you could join any team in human history to innovate with, which team would you want to join?
So to switch it up, I won't go with Shockley and others in the transistor. I think if I were to look at one team, I think and this may be a bit of a cookie cutter answer here. You probably have heard this one on the show before, but I think I would go back to Apollo and NASA. And part of the reason there is the innovation, the drive that came out of that, and the number of different things that we've used from the space program in practical life from just that environment, that would have been fantastic to be part of. I think that's a case where you had so many smart people that were given such complicated, challenging problems and a lot of pressure to solve those that it ended up being just a boom of new devices, new materials, all of those things. It's one of those things whenever anyone brings up, oh, why do we need the space program or why do we need to go to Mars or whatever, it's that's not practical spending of the money. But if you look at the things that then I think that would be an awesome team to have been part of. And
Yeah.
still, even today, the innovation that goes into anything that has to go into space.
Yeah, and we've had lots of folks from NASA on the show, which I really appreciate because then we get to hear about all those cascading benefits too. So
Yeah.
my next question for you is if you could, what's something that really pisses you off or something that you just simply wished existed for your own pleasure in the world that hasn't been invented yet, that you would love to see in the world, but doesn't yet exist?
I think I'm going to go a little bit Star Trek on this one, but it's also driven by the fact that I live in the Boston area. My family's in Philadelphia, and I often make a trip from Boston to Philadelphia. This most recent one over Thanksgiving and Christmas, coming back with a 3-year-old and an 8-month-old in a car and being stuck in traffic for 8 hours. To me, it's something like a transporter, teleportation. Those are the type of things where when you're sitting in traffic and doing nothing but staring at the bumper of a car and maybe a bunch of cameras in the bumper of the car. I just that's something which I would love to have become a reality. I think there's also the cool thing is that when you look at innovations in the quantum world, they're starting to talk about how they can make those type of things a reality. There's quantum teleportation and still very far off. We're talking few to tens of molecules that are being transported or teleported, but maybe not a complete science fiction.
I love that. So if people want to get in touch with you, Rob, what is the best way for them to connect with you and everything that's happening with Metalenz?
Yeah, absolutely. So certainly you can look at our website. We keep that very up to date. Like you had mentioned, we'll be at Mobile World Congress. So if anyone is going to be there, we'll be at CES as well coming up just in January here. But also then if you want to reach out on LinkedIn, always glad to have a chat there. And yeah, I definitely always interested, whether it's people just looking for what it is we're doing with technology, or if it's someone who's looking to come and work at a very innovative company doing new things in optics.
Fantastic. Rob Devlin, thank you so much for joining me today on the show.
Yeah, thank you so much, Susan. This was really great.